Hello, everyone, and welcome to What's Up, the podcast where we talk about everything electrical and the future of the test and measurement industry. My name is Darcy, and I'm here to dive deep into some of the industry's biggest topics. Self-powered relays are becoming more prolific, and Nicholas Wetterstrand takes us through what actually a self-powered relay is and why it might be the future of the protection industry. So let's find out what's up with Nicholas Wetterstrand. Hello, Nicholas, and welcome back to the podcast. How are you doing today?
Doing great.
Great. Nice to hear it. And as you know, we always start the podcast with our power up questions, which are built to get your brain thinking and to get to know a bit more about you. So are you ready?
I'm ready. Let's go.
Okay. First question. Where is your next work trip?
Next work trip is actually to Kuala Lumpur, and I'm heading off on Saturday, so it's not too many days left.
Nice.
So IEEE conference that I'm going to speak to.
Fantastic. Quite far flung. You might get a nice tan.
Yeah, hopefully, but mainly conferences and airports, so
Not so glamorous.
not so glamorous.
You've been on the podcast with us a few times. What's the favorite episode you filmed?
The favorite one is probably about the digital substation. I really think that's the future for us, and yeah, I love that one.
Great. And if you could change one thing about the industry, what would you want to change?
Ooh, that's a tricky one.
Yeah.
Could be dangerous answers to that one. No, I think we have a very conservative industry, and everybody want to stick to what they've done in the past. So if I could change anything, I would love to see more openness and willingness to try new things and just be open.
Great. Thank you for answering those. Today, we're here to talk about self-powered relays. So tell us why this is such an important topic to cover.
It is important because they become more and more common in the network. It's not that they are new; they have existed for a couple of decades and so on. But it is increasing with the smart grid and the renewables and the distributed energy resources (DERs). It is a relative simple or basic protection normally. But it still have all modern features like communication and so on. But I think the most important is that it's powering up from the network, so it doesn't need any DC power supply, which make the installation pretty cheap. So it's an important part of the smart grid development.
And where can they be found?
Normally in lower voltage levels, where you normally connect renewables. So a guideline, even though it's not a strict rule, where we have transformers from 800 kVA and above, you can say, and obviously since renewables or they are increasing, then it will increase as well.
So today we're talking all about self-powered relays. So
Yes.
what actually is the difference between a self-powered relay and, a regular relay that we all know and love?
Yeah, exactly. You can almost hear it on the name, the self-powered part. So it's powering up from the harvesting the energy from the network itself that it's protecting. So it's made through the CT or VT, and it has a switched power supply that you power up the relay. So therefore, as I said before, the DC system, the battery banks are not needed anymore. And this is saving cost, and that is very important, of course, to have a smart grid function.
So let's talk a bit about testing then. So what would be the differences in testing both of those?
Yeah, from a testing perspective, and if you see from a relay protection function perspective, there are really no differences. It's a basic, standard, simple relay, which is fairly easy to test. But from a test equipment perspective, it could be challenging because you need enough energy to power this relay. And in that environment, there are some things that happens which makes it also difficult to get accurate results.
So you spoke a little bit about the actual equipment that you use there, which is our specialty, of course. So what are the differences between those? And can you just go a bit deeper into that for me?
Yeah, in normal operation, the relay is working as it should. You have a very stable network, and the induced distortions, if you will, by the harvesting is not affecting the network at all because it's stable. Also, if you go to traditional test equipment, which are more transformer based, they are again a more stable source, and that will again not be affected by testing. So like the Sverker 700 we have, it works perfectly fine, and you will have good results with that. But when it comes to three-phase relay equipment, which are more modern, we are using switched power supply, and switched power supply normally don't have the power and so on, and there are other things that happen. So power is one issue. Yes, there are switched power supply, and we have it that can provide the VA needed to power it up, but there are other challenges as well. The power up or the self-power relay normally get power from one of the phases, so it creates an unbalance between the three phases. And the third thing I would say is that it's a non-linear load, which also creates difficulties in regulation and measurement parts. So no, I remember one thing more. There's one more thing for
you can add as many things as you like.
Better mention them while we're here. So the switched power supply, it also creates distortion back, since you have a switched power supply in the relay and switched power supply feeding the relay. You get some kind of, I shouldn't say harmonics, but there will be distortion through there, and that's a challenge for the test equipment to get accurate results.
So it's the power source that can really determine actually the differences between the two and makes it challenging.
Yeah, absolutely.
So when it comes to distortion, which is something you mentioned, I can only imagine that has a huge effect maybe on the accuracy of some of the tests and results you receive.
Yeah, it's both the measurement of the output amplitude, so you get the right amplitude when you should have it, or what you desired, so to speak, and also the timing of the measurement. So the measurement of amplitude and timing, it's one thing. And then, since it's a switch power supply, you have also regulation of the amplitude to regulate that you get a nice AC out from the unit. And that is, again, difficult when you have a lot of distortions and unbalances, and it's easy that you get incorrect values.
So it sounds like it can be quite tricky then, I guess. So having the right equipment is fundamental.
It is. And like I said, this has not been a new thing. So there have been solutions available, and you can use compensation table or external accessories. We have seen that in the past. But we thought in Megger that we could do better than that. So we should be able to do three-phase test equipment, which has high power amplifiers which can cope with the energy required. And we work with the software algorithms for regulation and measurement to take care of the difference or deficiencies you have of these relays. So even though you have distortion, you have measurement regulation challenges and non-linear load and so on, we can still get accurate results.
And a huge part of what we do when testing is obviously having the right equipment, and that comes with a cost to it. And I know that people are always looking to have the most cost-effective ways to test their equipment. So can you just elaborate a bit more on how that fits into this narrative?
Yeah, cost-effective is necessary in many areas, but I think in particular for the smart grid, since now we're going down to lower voltage levels, and there you don't want to invest that much money because there are so many of them. So therefore, it's crucial that the network is cost effective, and self-power relay is a cost effective way, since you don't need this DC backup power, so you can remove the whole DC network with the power with the battery and so on. So that's one thing. And the other side, from a test equipment perspective, you don't need to invest a lot of money either, because it's a basic protection that you're testing. Three phases are many times required, or at least a wish that customers has. But you can do that with reasonable cost if you go with the Sverker, and they still have the capability of testing. So it's approximately double the price of a single phase test equipment, but it's about half the price of a more advanced three-phase test equipment.
Nicholas, you've just given us a fantastic overview of self-power relays, and they truly are very interesting. So is there one kind of key takeaway you want people to take from this?
If I make a short summary, then is that the self-power relay become more common, and they are necessary for the smart grid. It is a basic relay with basic functionality, but it's challenges for the test equipment. So we need the power. We need to be able to regulate, even though we have the non-linear loads, we have the imbalance between the phases, distortion, etc. So we need all that. And since it's a basic relay that you want to test, you don't want to use a sledgehammer to hammer a nail, right? So you want the right tool for the right job. And we have a solution available. It's the Sverker 900.
We love a bit of product placement for us there, don't we?
Yeah.
But it's the right tool for the right job.
Yes,
Perfect.
that's important.
Thank you so much for coming on again, Nicholas. I hope you enjoyed yourself.
Yes, I did. Thank you.
Great. Thank you so much. Thank you for watching and thank you for listening.